Have you ever wondered why dolphins are called the bats of the sea?
Dude, no one's ever said that. Who says that?
I say it all the time.
I've never heard you say that.
I say it. Hello, Dr. Chris, and whomever else you choose to show this to.
So, bats and dolphins, they have something pretty special in common. What is it?
Well, it's that they're adorable, obviously.
Close, but not quite. They're actually both experts in echolocation.
Ah, yes. The process by which an organism, such as a dolphin or a bat, produces sound waves and uses the returning echoes to determine orientation, avoid obstacles, and most importantly, detect prey. The animals use the echo delay to determine how far away an object is, and the interference and overlapping sound to determine the shape of the objects.
Exactly, well done! Echolocation is an evolutionary advantage for both bats and dolphins, as it allows them to locate prey through sound, as opposed to sight. Both animals hunt in dim light environments. Bats are nocturnal and therefore hunt during the night, and dolphins are marine animals, hunting in an environment where visibility is quite low. Echolocation also requires no extra energy expenditure, which is really important for bats while flying. Over 65 species of toothed whales, or odontocetes, and more than 700 species of bats use echolocation. But how did two seemingly unrelated groups of animals evolve to have such similar hunting mechanisms?
Well, I'm glad you asked, Jess. This seems to be a case of convergent molecular evolution. This is the process by which unrelated taxa evolve similar traits in response to natural selection or environmental pressures. Although bats and dolphins have very different anatomical features that allow them to send and receive sonic signals, they share common mechanisms for hearing and decoding the ultrasonic signals that they emit. Both taxa also show a gene sequence for the protein prestin, a protein that is expressed in mammals as outer hair cells. This increases the animal's sensitivity to high frequencies and allows them to detect any returning echoes. Scientists are even speculating that due to the presence of these same genes in their genomes, that echolocating bats and dolphins are actually more closely related to each other than other bats and odontocetes that do not echolocate.
Well, that sounds all well and good, but bats and dolphins are pretty different animals. One is aquatic, the other can fly, so obviously their anatomy, and even the anatomy of their sonar, is quite different. The path of echolocation in dolphins is pretty complicated. Sound is produced by forcing air through a pair of phonic lips, located below the blowhole. It then travels through the melon. Anyway, the melon, which is a specialized lump of acoustic fat, before emanating in a site on the forehead. Returning echoes are received via the lower jaw, the only other location in dolphins where acoustic fat can be found. I wonder if they did this on purpose.
Yes, well. Most bats, however, like humans and other land mammals, use their larynx to produce sound and emit it through their mouth into their surroundings. Usually the upper frequency of a bat's sonar is about 100 to 110 kilohertz, and these signals tend to be much longer and more varied than a dolphin's. This is due to the medium in which each animal is detecting its surroundings, as sound propagates much easier in water than it does in air.
Now listen to the sounds emitted by this Myotis volans bat as it hunts moths. The clicks increase in intensity as the bat homes in on its prey. This provides extreme precision and accuracy that allows them to snatch prey, like these unfortunate moths, right out of the air. Dolphins can marginally increase the frequency of their clicks, but compared to bats, their echolocation arsenal is much smaller. Their range for echo detection is different. Bats are able to detect in a much wider arc than the dolphin's much more streamlined zone. This would probably mean that the dolphin's use of echolocation is much more directed at food rather than obstacle detection and orientation, as seen in bats.
Alright, so let's recap. We've learned that both dolphins and bats produce an ultrasonic sound called echolocation, which basically gives them a mental image of their surroundings and prey. We've also learnt that the production of this sound is very different in both organisms, due to the medium of water versus air. Finally, there's this crazy concept of convergent molecular evolution, which could completely revolutionize the way that future scientists decide which organisms are most closely related and their taxa.
That's pretty amazing. Ultimately, echolocating bats and dolphins, though they look absolutely nothing alike and live in totally different habitats, are more closely related to each other than to other fruit bats and non-echolocating odontocetes. I wonder how many other animals are genetically related that we don't even know about. Probably a lot. Hashtag science. Well, that's all we've got time for.
Wait! I have one more joke. Are you ready?
I'm ready.
Why did the whale take the dolphin with him when he went to play cricket?
Why?
Because he wanted to use him as a bat! Done.
Peace out!
Do some things. Welcome to the science program. This isn't starting well. They're not staying on my head. Oh,
Freeze.
hang on, I need to sniff. Ah! I'm itchy. What are you looking at?
The sun, I have to sneeze. You got your page?
It's you.
Oh, what?
Sneeze, my love.
Peace out!